if you go to, and a couple things we should say, you'll notice that electrons that are in the second energy level could be on one of two floors. It could be on the first floor, the first sublevel, or the second floor, the second sublevel, the P sublevel. Electrons in the P sublevel, on average, are a little bit further away from the nucleus and have more energy than the electrons belonging to the S sublevel. Questions? Yep.
Is it possible that n=1 electron can be found on the second level of the...
Could you find an n=1 electron out here? I mean, statistically it's possible. It's just highly unlikely. Okay? It doesn't, wave mechanical model, the quantum nature of the electron, yeah, we don't, so that's not possible. Yep.
So really it's just like you're more likely to find, say, an S, like for orbital 2, you're more likely to find an electron in the, from the S layer in that area, but it can really be in like the P layer. It's just
right. Yeah. It's just, but on average, if you're you're going to start putting some money down, betting money, you're going to be betting that the second energy level. So we would refer to. Let me talk about a little bit of language here. When we talk about the energy level, we use a coefficient. So if I'm talking about the second energy level, I would use 2. And then if I'm talking about the P sublevel, then I would write 2P. So that's a 2P sublevel versus a 2S sublevel. Okay, an electron belonging to the 2P is going to be, on average, further away from the nucleus most of the time compared to a 2S electron, and will have more energy associated with it, always, than a 2S electron.
Can you, like, jump to a sublevel?
We're getting there. You just so we're going to get there. Okay. Yeah. Other questions? If you go to the third building, the third energy level, guess how many floors?
3.
Yeah. There's the S, script L equaling 0, the S sublevel. There's the P sublevel, and there's the D sublevel. Where the 3D is going to be greater in energy than the 3P. The 3P is going to be greater in energy than the 3S. Notice that a 3S electron has more energy than a 2P electron. The 3S electrons on average are further away and have more energy associated with them. Questions? Guess how many sublevels are in the fourth?
3.
There's 1 in the first energy level. How many sublevels in the second? 2. How many in the 3?
3.
How many in the 4? 4, right. So it's the first floor, second floor, third floor. So it's the S, the P, the D, and the F. Now, how many sublevels in the fifth energy level?
4.
5.
5, guys. Why are you resisting? Do you understand the logic here? Julia? Okay, so there are 5. All right. Actually, there was a correction in your packet. I think we made it. I think we took it out. Yeah. It's already been. Yeah, I think it was white outed. So yeah. It was white outed, so we're okay. All right. So there are 5 in the fifth energy level, and you'll be happy to know that after the F, we go alphabetically. So then it's G, H, I, yeah, okay. So after that, it just becomes alphabetical. Yep.
How many are there in the 27th sub-level? Because then you're out of letters.
Whoa. You said how many are in the 27th sub-level? Okay,
Wait.
When you say how many, what are you talking about?
Wait. Never mind, I forget what it was.
He means what letter?
Yeah.
He means what?
What letter?
Oh, then we don't worry about it. It just doesn't become an issue. Yeah, you can start, yeah, it just doesn't become an issue. Other questions? Okay, so this is why we say script L can have values ranging from 0, that's our first floor, and how many floors? Well, it's always 1 at the sub energy level you're talking about, -1. Because again, script L equals 1, 2. So when you said 4, be careful. You have to be careful whether you're talking about script L or the number of sublevels. If I ask you, what is the maximum script L value for a sublevel belonging to the third energy level. Well, the third energy level has 3 sublevels. Okay, the first floor, second floor, third floor, but that's script L0, 1, 2. So 2 is the highest script L value. You guys understand? Questions? Okay, not bad. Well, it turns out that, you know, when you go into the building and you find the floor that you want to be on, you know how floors can be broken up into rooms? Oh, yeah. It turns out that the sublevels are actually broken up into individual rooms. Of course, we don't refer to those as rooms. We call them orbitals. So our third quantum number is the m sub L, script L. This is the magnetic quantum number. And the magnetic quantum number, script m sub L, can have values ranging from negative script L all the way up to positive script L. Those are the possibilities. And what it specifies is the exact orbital the electron belongs to. It tells us which orbital the electron is in. Now, if you go into the first building, it has 1 floor, okay, just 1 floor. And it turns out that that first floor only has 1 room. It's like walking into a barn that doesn't have a loft. You walk into the building, it's 1 floor, 1 room, it's just all one and the same. We refer to this orbital as belonging to the S sublevel as an S orbital. So we would say m sub L equals 0. Or another way of saying it is that we're dealing with an S orbital. If I go into the second building, I go into that first floor of the second building, and lo and behold, I find that that first floor is just 1 giant room. It has an S orbital. It's an S orbital. The floor and the room, it's all one and the same. Or we can say m sub L equals 0. When I go to the second floor, it turns out that the second floor is made up of 3 rooms. Okay, there are 3 orbitals that make up the p sublevel. There are 3 orbitals that make up that second sublevel. I'm going to denote this. This is not going to be true in terms of how it actually looks. We'll do that in a moment. But I'm going to do it because it'll allow you to see how we organize the information, and it's just easier to deal with. I'm going to separate and represent using hatch marks. I'm going to say that this represents 1 orbital, this represents another orbital, and this represents another orbital. It's not how it actually looks in the atom. I'll show you how it looks in a moment. But what this does is it shows you some useful information. It shows that, first of all, we're going to say that this is a p orbital, that's a p orbital, and that's a p orbital. There's 3 p orbitals. This is the p sub x orbital, or if you prefer, m sub L equaling -1. This is m sub L equaling 0, or the p sub y orbital, and this is m sub L equaling +1, or the p sub z orbital. When we name m sub L values by number, we include the sign. So if it's a 2, we put +2, we put the plus sign in. If it's 1, we put the +1 in. We don't just put down 1. So the sign, including the positive sign, is not simply understood. We actually write it in. Okay, much like you would do if you were dealing with a barium +2 ion, you wouldn't just put barium 2. Okay, you put the plus in there to drive the point home. Now you'll notice that I've named these 3 orbitals, these 3 rooms that make up a p sublevel, as the p sub x and the p sub y and the p sub z. Why did I use those letters? Well, it refers to the Cartesian coordinate system. It turns out that the shape of the orbitals is not all the same. They're not all the same shape. You look up here, and it looks like as though, well, what shape makes sense, guys? What's just intuitively obvious? Spherical, right? Spherical orbital would make sense. And that's the way s orbitals are. S orbitals are spherical in nature. Okay? So this is actually a pretty good representation. Okay? You have to picture the rest of the sphere around the nucleus, but that's what an s orbital looks like. P orbitals are not spherical. And that's why this really doesn't truly reflect what it looks like. Let me show you what a p orbital looks like. P orbital is too low. So this is the nucleus, and then on the other side, you can see I have sometimes referred to as a dumbbell shape or a two-lobed, L-O-B-E. Okay, it's a two-lobed orbital. This is one p orbital. Which p orbital it is? Well, it depends upon which axis it's on. If I decide to, and it's really, which axis you're dealing with depends upon how you're looking at things. But if we go with what is customary, which is usually, you guys think of this as the x-axis, right? When we draw it this way, this is the y and that's the z, okay? All right, so this would be a piece of y orbital. You want to know what a piece of x orbital looks like? All I have to do is just label that as the x-axis, okay? If this is the x-axis, so the lobes are situated and symmetric about the axis they're on. So the piece of x is situated about the x-axis, the piece of y about the y-axis, and the piece of z situated about the z-axis. Well then, wait a second, then what does this p sublevel look like? Well, if you put all of them together, that's what p sublevel looks like. In your packet, if you flip over to page 13, at the top, you can see I'm showing you the piece of x, the piece of y, and the piece of z. And if we superimpose them all together, we get a p sublevel. I got a better picture here. I'll show you. I'll pass this around a minute. You're going to see the piece of x, the piece of y, and piece of z. And if I superimpose all of them, that's what a p sublevel actually looks like. It looks like sort of like a bumpy sphere. Okay, so piece of x, piece of y, piece of z, and that's what the p sublevel actually looks like. Again, piece of x, piece of y, piece of z, superimpose them all together, that's what one p sublevel looks like. So p sublevel is not spherical, it looks sort of like a bumpy sphere. Questions at all? So far, so good? Okay, so we go out to that third energy level, third building, which has 3 floors. We go into the first floor, one giant room, one orbital, and s orbital. We go to the second floor, and sure enough, like any other second floor we've run into, it has 3 rooms. It has 3 orbitals that make it up. It has a piece of x, a piece of y, and a piece of z. Oh, before I move any further, let me point something out. You'll notice that the piece of x, piece of y, and piece of z, on average, belonging to that same sublevel, they're all the same distance from the nucleus on average, right? So, if we were to compare a 2p means a second energy level, p sublevel. If I want to specify the orbital, I can call this the 2p sub x. The 2p sub y orbital would be a different orbital belonging to the same sublevel. Orbitals belonging to the same sublevel are said to be degenerate. Okay, the word degenerate, if someone says you're a degenerate, they're not paying you a compliment, okay? That has a different connotation. But here, the word degenerate means equal in energy. Orbitals that belong to the same sublevel are said to be degenerate, which is simply another way of saying that they're equal in energy. So an electron belonging to the 2p sub x and an electron belonging to the 2p sub y would have the same exact amount of energy, even though they were in separate orbitals. And that's because they belong to orbitals of the same sublevel in the same energy level. Questions? Okay, so we come back to this third energy level, this third building, which has its first floor, its S sublevel, which has 1 room, the S orbital. We go to the second floor, the second sublevel, the P sublevel, with it has the P sub x, P sub y, and P sub z. This time it's the 3P sub x, the 3P sub y, and 3P sub z, because we're in the third energy level. If we go to the third floor, which is our third sublevel, that's script L equaling 2. Remember, it's counterintuitive. You would think it's a third sublevel, so it should be 3, but it's not. It's 1 less. It's 2. In other words, what we call the D sublevel, it turns out, guess how many rooms are in that floor? 5. See the pattern? 1, 3, 5. There are 5 orbitals. So I'll separate those again using hash marks. We have the script M sub L value equaling -2, -1, 0, +1, and plus 2. Remember, the IMSA values go